The topic today is mega constellation monopolization, combating the takeover of low Earth orbit. And our panel moderator is Dr. Arup Dasgupta. Dr. Arup Dasgupta is a former deputy director at ISRO's Space Applications Center, specializing in satellite communications and geospatial technologies. He is currently an advisor at Geospatial World and an independent consultant. His work focuses on space policy and the integration of space and information technologies. So, Arup, all over to you, and we look forward to a very interesting discussion.
Thank you, Shreya, um, and a warm welcome to my panelists as well as the audience. We have a very learned panelists in this discussion. Um, so I'll just give a brief introduction to the three of them. For the first one is Blaine uh, Curcio. I have got that right, I hope.
Right, thank you.
My pleasure. And he is a consultant and an analyst specializing in space and satellite communication sector. And he has particular emphasis on the Chinese burgeoning space industry. He has worked with several organizations in China. And so therefore, since we are going to talk about the Chinese yeah, we're going to talk about the Chinese efforts in the use of LEO for their constellation, so this makes a lot of sense. Our second panelist is Dr. Fabio Tranchetti. If I got the name correct, I hope.
Yes, you did. Thank you.
And he works as an associate professor at the School of Law of Northumbria University in the United Kingdom. The recipient of the 2019 International Institute of Space Law Young Achiever Award, and he is also director of the International Institute of Space Law. I'm sure he will look at all the legal aspects which relate to the subject of today's discussion. Our third panelist is Dr. Jayant Murthy, who is a distinguished astrophysicist, and he is renowned for a lot of his extensive work in the ultraviolet astronomy, as well as in the study of the interstellar medium. Dr. Murthy has a distinction because he has an asteroid named after him, and this was done by the International Astronomical Union in recognition of the tremendous work that he has done in this area of astrophysics. So a warm welcome to all three panelists, and let me now start by first giving a brief on the subject that we are going to talk about today. So as you are aware that we are having a huge number of these constellations going up. Starlink is already there. OneWeb is also partially there, and Kuiper is just, I think, waiting for some approvals. And then the Chinese, of course, are coming up in a big way, and so we're soon going to have not thousands but hundreds of thousands of these satellites all whizzing around in the low Earth orbit, right? So the question is, on the one side it looks great, but on the other side there are issues which we need to discuss. And these are basically, it is looking like the way, kind of people are, kind of pushing and shoving and trying to get into this LEO orbit. And in that sense, it looks like some of the big players are going to monopolize this orbit, which is thus certainly not something that is good. A number of small countries, small organizations are going to get left out unless something is done. The other point, of course, is that the crowding in the orbit is going to create an enormous amount of problems in terms of the debris, because in the low Earth orbit, the solar activity does have a tremendous effect, and we have seen a large number of Starlink satellites falling to Earth because of the solar activity. We also see that so many launches is leaving a lot of debris in the form of this rocket parts and so forth, which are going around in the orbit and are going to create problems. One problem has already been seen, that astronomers looking up through a telescope are seeing streaks of light, and this is definitely not something that we would want to do. I mean, Earth-based astronomers are going to face a lot of problem. And apart from this, then there are so many other issues. The satellites burning up in the atmosphere is going to lead to pollution. If one or two satellites burn up, that's fine. But if you have hundreds of them burning up every day, that level of pollution is quite something different. So to be able to look at some of these issues in a more structured manner, I organized the discussion in about 5 sections, and we'll go through each section, and we will have the panelists express their opinion on this, and try to see whether there can be some sort of a some sort of a recommendation that come out of this particular discussion. So now let's look at some of the questions, and the questions that I have raised. The first question that I asked is that do we really need to have these huge constellations in low Earth orbit? I mean, what is the purpose? And can this purpose be served by any other means? So, this is basically a very fundamental issue, because if I look at Starlink, which is now currently working, and I look at the kind of costs that are involved, Starlink, at least in India, for example, although we have now 2 Indian entities who are in collaboration with Starlink and trying to bring Starlink over to India, but if you look at the costs, you see that the Starlink is going to cost an order of magnitude more than the services that are already there. Now, about 95% of India is covered by the terrestrial services. And I'm sure this must be true for most other countries. So, is this 5% extra to be covered at such a high cost? Are there no other solutions? For example, we have the high throughput satellite systems, which are also very much in operation. So, we would like to therefore address this question, and may I request, I'm sorry, my papers are all getting mixed up. So can I request Blaine to start off the discussion on this particular topic?
Absolutely. So thank you for that introduction. And maybe just to give a very short amount of background on SATCOM more generally, satellite communication. So I think if we think about the challenge that Starlink and other constellations are trying to solve, it's bringing bandwidth from space effectively. And to your point, one of the other ways to do that is through geostationary high throughput satellites, which has, it's a tried and proven technology. 20 years we've had high throughput geo satellites, and for 60 years we've had regular geo satellites, let's say. I think the one big innovation that there's, let's say, two main points as to why low Earth orbit is important in connecting people from space and bringing bandwidth from space. On the technical side of things, it is objectively lower latency. So one of the challenges of geostationary satellites is that you have a relatively speaking, long latency, maybe a quarter of a second delay, due to the fact that these satellites are 36,000 kilometers above the Earth, and so for the signal to get from Earth to satellite and back is a bit of a delay, and that's a factor that you can't break the laws of physics. So that's a factor that will be there forever. The question is, how big of a factor is that? And frankly, for most uses, it's not a very big factor. But nonetheless, if we're thinking, are there other ways that we can solve this connectivity problem using GEO? That is one unique aspect of LEO that GEO cannot solve, is like very low latency communications. And so we have to give credit where credit is due. But the other big innovation that Starlink has and others have started to achieve is just economies of scale. I mean, GEO communication satellites have historically been ordered in quantities of 1 or 2 satellites, and it takes years to make. And so every piece in every satellite is very kind of turnkey, made to order, customized, etc. And if we compare this to Starlink, I mean, there's 7,000 Starlink satellites in orbit today, and if we think about how that's impacted the supply chain, how that's impacted all of the inputs into these satellites, the cost of everything comes down dramatically when you go from an order quantity of 2 to an order quantity of 2,000, right? And this is something that we're starting to see green shoots of in GEO. We have a number of companies building small GEO satellites. So these are GEO satellites that would be a few hundred kilograms as opposed to a few thousand kilograms, let's say. And they're trying to build these satellites in batches. And still, we're not reaching anywhere close to the thousands of satellites that Starlink has. But you have companies like Astronomical in the US or Swiss to 12 in Europe, or Reorbit also in Europe. That are talking about building a handful of GEO satellites at a time, and eventually maybe 10, 15, 20 GEO satellites at a time. And that should help to make the cost of bringing connectivity from GEO down rather considerably. But I think, getting back to your question, I mean, that's the need for LEO right now, or the use case, the strong argument for LEO is these constellations are by nature batch manufacturing, and they're just massively ramping up the supply chain, and that's completely changing the economics. And I guess one last point I would mention is, it's still to be determined to what extent that impact on the supply chain is going to impact GEO. So if you're a GEO manufacturer and you now want to buy an antenna or Star Tracker or some other widget, a lot of the suppliers of those things are now building in much bigger quantities because of Starlink, and maybe they can give you a better price than they could 5-10 years ago because they're building in bigger quantities for Starlink. And so, yeah, I think LEO is definitely, it brings a unique value proposition in terms of latency, but that's really the only secret sauce. I think everything else, it could also be applied to GEO, at least to some extent.
Thank you. This is a very you raised in the sense that you do have advantage of economy of scale once you are going to build so many satellites all at one time. But then I also like the point that you made about the mini geostationary satellite. This is something that's going to be quite revolutionary. Would Jayant like to also add something to this?
Well, my only comment is just that I think the business case has to be thought out and the use case has to be thought out, because, as you said, the latency may not be important for many people. For instance, in rural areas, one might think of farmers getting weather forecasts or consulting on agricultural videos. And that latency is not so important. If they're doing gaming, of course, it is important. Maybe it's more important for chats. So I think it's worth thinking of how much the satellite constellation is necessary, as opposed to just remote coverage.
I think you brought out a very, very important point. I mean, latency everybody talks about, but that latency is for real time or near real time. Okay, so if you're gaming, yes, or if you want to have an extended chat, yes. But then if you just want information to be passed on, or a query to be made and answer to be got, I don't think latency can play such a important role. And therefore, another point which comes out is that, okay, I for latency's sake, I'm going on to LEO. But the question is, whom am I addressing then? I mean, people on the ground are going to have a much cheaper option on the terrestrial distribution. So the issue that really comes up is that such a constellation will really be very important if there is a situation where the terrestrial system fails. For example, in a big disaster, right? Flood or something, or cyclone. Yes. Then definitely the constellation is going to be a very good and very reliable system, because everything else has failed. But then again, my question is, do we need to therefore spend so much of money for this one thing? Or is it really something that's got to do with the defense, which nobody wants to talk about? Is that the real elephant in the room? So, Fabio, would you like to add something to this?
Uh, well, I mean, the only point that I could add are legal consideration, of course, with being a lawyer. The last point that you actually mentioned is very interesting because beside the business case that we were discussing now, when you plug into the conversation the military implication of mega constellation, and that changes completely the dynamics of what we're discussing from a legal point of view. Because remember that under the international law that applies to outer space, all these companies need to receive an authorization by licensing authority at domestic level. So the question is whether or not these companies have been licensed to provide, what kind of services or what kind of activities have been allowed to undertake for civil purposes or military purposes. Because we all know the Starlink has been used in a military context for military application. So that raises a significant question because remember that under international law, then what the company does falls back on the state that has authorize the activity of that company. So there are a number of implications that go beyond the mere law in terms of international politics, international relations. So I would definitely look into those legal questions, yeah, that would be my point to add.
So maybe then you can continue with the second point that we have, which is basically how do we manage the low Earth orbit? There's going to be tremendous congestion. In fact, there are studies which have shown that if you have so many satellites in the low Earth orbit, the chances of a collision goes up to almost 40%, and that is huge. So who decides how the axis is going to be? Uh,
Right.
Uh, is it the UNUSA or UN itself, or is it going to be the ITU, or is it going to be the countrywide organizations like the FAA in the US, or wireless program coordination in India?
Right. That's the key question. That's I wish I would be able to give an answer to that, but it's a very tricky point. It, this is a classic situation, classic example of technology moving so fast that it's extremely hard for the law to keep up, especially at the international level. But when you think of space activities, always think about two-dimensional, the international dimension and the domestic dimension. In terms of what the United Nations may do, you mentioned UNOSA, United Nations Office for Outer Space Affairs, and all the committees that exist, COPORS, legal and it's a technical version. What they can actually do is attempting to find some common ground the country can use to lay down some common rules that operators should follow. But this is something that, of course, the United Nations has been working on in the past few years, and the most visible outcome of this that is relevant to our discussion is the adoption of the long-term sustainability for space activity guidelines, with, however, the caveat that these are guidelines and their implementation is up to the states and to the operators to comply with it. There is no formal obligation internationally for these guidelines to be implemented, and that's the major limit that the United Nations faces. And that I don't want to go into a long discussion, but that goes back to how the United Nations works. And operating by consensus is very difficult to have a common ground, a common agreement among countries. So finding this instrument of what you call in law, soft law, so non-binding instrument, is a way to move forward discipline without imposing any formal commitment upon countries. What we see, however, is countries implementing these guidelines, which is a good sign. And so this bridge between the international and the domestic level, however, as I said, it is more a voluntary action rather than an obligation that comes from the international level. So in the case of mega constellation, as I said, it's very difficult to come up with any real concrete instrument that will bind any country. So we have guidelines. So at the moment, I think the most important area where an impact can be done is at domestic level, at the level of the country, which is actually giving the authorization for these satellites, thousands of satellites like Blaine was describing, to be deployed into orbit. Because that's the domestic authority is the one that knows what the activity is going to look like, how many satellites, for which purpose, what will be the location, and so on and so forth. And it's up to the domestic authority to make sure that the deployment of that constellation is not going to cause interference, so finding the application with the ITU, and to make sure that this system, there is a certain level of safety that is acceptable, that does not endanger the low orbital population. And that's so we enter again in another discussion about space debris. I don't want to delve into that now, but I think this is all the questions that are on the table. Yeah, so this difficult balance between the domestic and international level. At the moment, I think the domestic level is the one that has the most hands, more capability to have a direct impact on the constellation.
In fact, I was reading that in the last ITU conference on the frequency allocation and so forth, the WRC, which was held in I think Dubai. The most contention issue was the space and orbits. So I'm reminded of the early days of communications when the slot in the geostationary orbit used to be highly contested, and people would rush to make reservations, so to speak, of a slot, and then they had a limited time in which to get their satellite up there. So it seems like this may become about 10 times more complex in the low Earth orbit for the mega constellations. Just my view. Jayant, would you like to add something here?
Again, I don't know very much about the business case, but what astronomers are concerned about is that we've basically lost the sky. And there are two aspects to this. One is that, if you look at it purely in an economic case, we're building expensive telescopes. Vera Rubin is coming online in July. And with the number of satellites up there, you're losing a lot of the sky just because of these trails, as you said. And these have impacts on things like near-Earth asteroid detection and stuff like that. We're also losing the cultural heritage that we have. We've had thousands of years of looking up at the sky and seeing the Milky Way and constellations. And now, again, we've lost that, and we've not lost that organically. We've lost that, or we've not lost it as a result of any discussion. It's just been taken. People have made decisions without consultation, and I mean, the sky is a natural resource, just like anything else, and we've lost that. So that I know there are discussions. It's even worse in radio astronomy than in optical astronomy, but I do think that this is an aspect that does need to be considered.
More like the gold rush. Everyone for him. Blaine, would you like to add something more to this point before we move on?
Sure. I think just one consideration, or one maybe bit of historical context. I mean, it's been alluded to already a little bit, and you just mentioned gold rush. I mean, the idea that probably about 10 years ago, there was this gold rush of non-geostationary spectrum filings where your Starlink, SpaceX, and Thales Alenia Space from France, and OneWeb, and a bunch of, mostly European and North American companies went and filed for the prime spectrum in low Earth orbit. And we've seen in the years since a fair amount of contention there. There was an interesting, and I think maybe still ongoing in some countries, court case in Europe about this Clio Connect. It's a Sino-German joint venture that had some filings that they had acquired through Liechtenstein. And it's a point worth thinking about, is it entirely fair that we had this gold rush in 2015 where all of these primarily Western companies were sitting at the table carving up the most prime pieces of low Earth orbit real estate and to the detriment probably of everyone else. But I would highly recommend any of our viewers to go and check out the Clio Connect case. It's a really fascinating and in some cases comical case. There's been some really just interesting ongoings there. So I would recommend it.
Thank you. Jayant, would you like to continue on the issue of the pollution? I mean, you talked about the optical pollution as well as the radio frequency pollution, but there are many other issues of pollution. Would you like to give us some ideas that you may have on this? You know,
I've I've only seen things off and on. Things like when the satellites come down, you're dumping material into the upper atmosphere, which is a problem with really unknown effects. Again, I don't know. I've heard people say that maybe the quantities are not that much, but as we put more and more up there, then certainly the impact is going to be greater and greater. So I think this needs a little discussion. I think we're in a rush to grab the spectrum. People are selling it, and a rush to commercialize it. I do think it deserves some discussion before we make these long-term changes that are harder to walk back.
in fact, I was reading in a fairly good, very detailed article in Nature where they said that, with these so many satellites burning up in the atmosphere, the amount of aluminium in the stratosphere is increasing. I didn't go to the greater detail of that paper. And the other thing that they said was that, with so many satellites up there, literally jostling for space, the chances of collisions are going up by nearly 40%. And the worst part is that apparently because these satellites are in low Earth orbit and they are traveling very fast and they are in your view for a very short time, so the ranging of the satellites and determining the exact position of the satellite is also highly compromised, which means again the chances of collision are very high. I don't know. Would Blaine like to add something on this?
It's a little bit outside of my area of expertise, but I would mention that the chances of collision, high as they are, they only get higher if we don't have coordination between the big players that are launching lots of satellites. And this is something that I work with a little bit directly in trying to bring together, companies from China and the U.S. being the two, countries, that are launching the most satellites. Is that you have these. Obviously you have SpaceX and Iridium and OneWeb and so on. And then you have these Chinese aspiring mega constellations, which have now launched more than 100 satellites between the two of the two main projects. And there is not a lot of coordination between these two sides. And that's only going to become more critical as both sides are launching more satellites. I would imagine that, 18 months from now, China will probably have more than 1,000 communication satellites in low Earth orbit. And if they're not then coordinating at least a little bit with players like SpaceX and OneWeb, it's almost asking for trouble. Really, it's not a good idea.
Would you like to continue on this particular topic that's on the technical and economic challenges which are there in this whole utilization of the low Earth orbit? Blaine.
Sure. So I think the economic challenges are probably the ones that I'm more familiar with. It's as you alluded to at the beginning of this talk. It is a very expensive proposition to launch a mega constellation to low Earth orbit, and I think the reason, or one of the reasons, that Starlink has been at least moderately successful. There's a couple of reasons. They have a fair amount of support, it seems like, from the U.S. government and military in terms of contracts there. But then also, for better or worse, Elon Musk is a very well-known, famous person, and there's a lot of people that are almost like disciples of him, where they're willing to say, okay, I'm going to go and proactively buy Starlink just to support the cause. I want to get people to Mars, or whatever, whatever the narrative is. And I think that it doesn't, if you can get 1 million people all around the world doing that, that's already a pretty good start in terms of, 1 million people, $100 a month, $100 million a month. That's $1 billion plus per year. It doesn't pay for the whole constellation, but again, it gets you pretty far along the way. And, 1 million people is a lot, but there's a lot of people in the world. So I think that the big challenge there in terms of economics is just, again, it's a very, very expensive proposition. These satellites don't have a very long lifetime. So 5 years you have. And if you think about how long does it take to actually deploy the constellation, it takes a couple of years. And so by the time the Constellation is finished deploying. Some of the first satellites are already maybe 40% through their lifetime. This is a challenge we've seen with OneWeb, where they had launched a bunch of satellites, and then they had some issues with COVID and with the Baikonur the satellites getting stranded in Kazakhstan. And the next thing you know, by the time their constellation is completed, some of their first satellites are getting close to end of life, and that makes it really, really hard to have any kind of momentum. And so, yeah, I think it's definitely a big challenge to justify the cost of a $10 billion or what a $5 billion, however much constellation, when you consider all of those challenges. On the technical side, I mean, we've seen things like laser communications have been a topic for a very long time, and it seems like everyone is still having trouble with that, except for probably Starlink, and then a few companies in China seem to be making some progress. But for some of these constellations, they like Telesat Lightspeed, for example, is seemingly, they have the funding now. They're starting to move forward with it, but they talk about using laser comms. That's going to be challenging, given that it's such a complex technology. I mean, you're talking about having threading a needle through space several hundred kilometers apart to two satellites, and they're both moving at a few kilometers per second, and it's science fiction, more or less. And there's a lot of those types of technical challenges, things like making sure that you have enough propulsion, enough fuel, and enough precise enough propulsion systems to be able to maintain the exact orbit that you need to maintain, and all of these other things that, I mean, it's, in a way, it's the most exquisite orchestra that anyone could have ever imagined, and you just have this whole orchestra that you need to be conducting in space, and it all needs to be working pretty much in sync, and that is a very, very, very complicated challenge.
Yeah, in fact, another thing that I thought of was that if you're going to have an operational constellation like this, and you're going to have the satellites dropping out at the end of life or due to some other reason, then you need to have to be able to maintain the quality of service. You will need to have backup satellites which should be launchable in a very short time. And also then one question that arises, which again relates to what Fabio spoke about, is that because if you want to have a long-term space sustainability, then also you have to have a planned deorbit. So when your satellite is reaching near the end of life, instead of waiting for it to die on its own, you kind of deorbit it. So these are some of the issues that technically and economically are issues of importance, which I think I can't say that they have not thought about it, but people are not talking much about it. Also, there's one more issue, that is, in these cases you need inter-satellite links, and these are most probably optical, are they not?
Typically, yes. I think you can have radio inter-satellite links, but optical makes it, optical makes more sense.
So given all this kind of cost that we are talking about, do you think ever that these satellite-based services, the LEO constellation services, will ever be able to even match the kind of cost that is there on the ground today? I mean, they have to come down and at least
well, we're seeing that a little bit already. I mean, I think Starlink, as an example, in some countries, they are specifically pricing their service at or slightly below the level of terrestrial communication. So in places like Italy, Spain, certain other European countries, even the US to a certain extent, I think in Italy right now, Starlink is like 30, 35 euros per month or something like that. In the US, it's around $100 per month. And I know in the US, that is roughly what you'd pay for home broadband internet. And I think when you look at the economics of Starlink, I mean, it's now, I think the 2024, you look at like Quilty Analytics or other companies that make estimates for Starlink revenue, it's in the $5-ish billion per year, or $5 billion in 2024, and growing at like 50% per year. I mean, it certainly looks like they're at cash flow break even, or potentially even just like overall break even, and they've said such. So I think it's a question of scale. In terms of scaling up a large number of customers in a relatively short period of time. But once you can do that, I think the economics start to look fairly attractive. And I mean, just one thought exercise is, let's say Starlink, $10 billion to deploy the whole thing. Maybe it's more, but let's just say 10 billion. If we think about, in the US, you had the mobile network operators deploying 5G. They spent tens of billions of dollars on just 5G spectrum. And then they had to build all the 5G towers across the entire US. And there were, hundreds of thousands of towers across the US. To build a 5G network across the entire United States probably cost upwards of $50 billion. And Starlink is obviously, you can't use Starlink in very, very densely populated areas in the same way that you could use terrestrial 5G. There's not enough bandwidth. But if we think about it as a blanket service, it 10 billion for a global service, it's like, okay, well, let's say 1/5 of that we allocate to the US, $2 billion compared to 50 billion to build a 5G network. The economics are not as bad. But again, I think the biggest challenge is just you have a 5-year-ish time window to ramp up the number of subscribers to several million. But then every additional subscriber at a certain point is just extra money. And I think part of the reason that we've seen Starlink be able to be so aggressive on pricing is that they reached a critical mass of subscribers that more or less paid for their ongoing overhead costs and everything else. And so now, again, everything is kind of, it's just free money to a certain extent if you get more subscribers at this point. And so, I think it's also just the last point I would mention on this is that it's noteworthy to see that the change in language that mobile network operators have been using to describe Starlink, where now you are seeing CEOs of big telcos saying, yeah, Starlink is actually kind of a threat to our core business, at least a little bit. And nobody was saying that 5 years ago.
That's true. There's a very interesting letter to the shareholders of Viasat, which makes exactly the same point. Okay, we're really nearing the end of our discussion, and I'd like to give some time to Fabio for the issue of debris and handling of the debris. And we talked about the long-term sustainability, but beyond that, what can we do?
Well, what can we do? Again, it's we need to think about this from a double perspective, internationally and domestically. But just to give you an example, I mean, countries are start taking matter in their own hands. Just a few days ago, the Chinese astronauts on the Chinese space station, they put a shield to protect the station from impact with debris, and that tells you that the risk is there. Just that we take the matter in our own hands and we protect our assets. Basically, that's the message. Again, internationally, I wanted to make a couple of remarks about what was said before, because Blaine mentioned the fact that we are basically creating our own problem. And if you think about this from a regulatory perspective, that is exactly the picture, because one of the problems, we put all these satellites in orbit, thousands and thousands of them, and the Chinese are coming, and potentially other European Union, maybe they will send their own constellation, and so on and so forth. So the numbers are going to multiply. And so this system could potentially work only if we would know what is happening in lower orbit. If it will go a global system of traffic surveillance, traffic management, and there is not that system. There is no coordination whatsoever among different parts of the world. A US operator read and does the same data in totally different way from one in Beijing. They do not communicate with each other. So there is no obligation to remove debris from orbit internationally. There is no obligation to notify about potential collision. There is no mandatory system of warning and so on and so forth. So we're really opening the field for collision and a cascade of consequences. So once again, internationally, we have just non-binding requests for removing debris from orbit or for lowering the debris and make them burn by atmospheric re-entry. But again, those standards have been updated recently also to lower the number of years that an operator is required to make sure that the satellite burns with re-entry. But we are talking about smaller numbers than the one that we are experiencing now. So there's again the problem of international law is how we catch up. I mean, what we drafted 5 years ago is already outdated. So there is a process ongoing of trying to update what was already agreed a few years back. But again, it takes time and then countries need to approve. So again, we fall back domestically. Every country that licenses the activity of a satellite operator, even more so in the case of Constellation, is supposed to require that operator to present, when applying for a license, a debris mitigation plan, a plan that explains the environmental impact of the activity, and to prove the technological ability to meet that plan. The question is whether this is done seriously when the license is done, when the technology is seriously tested, whether all the safety implications are seriously tested, or the licensing authority is under pressure, to give the license because the economic cases, business case we were discussing earlier. So that is the question. Of course, only the licensing authority knows. But again, I think domestically at the moment is where you can have really an impact to make sure that the operator acted consistently, responsibly, and if there is a warning, then warning is of a potential collision, that warning is shared, with the international community.
Okay, so I think I'll take last comments from Jayant and then Blaine. Jayant, what do you think? Where are we headed?
From what I hear, I'm surprised to hear actually that Starlink is so competitive economically. I had thought that a lot of it was subsidized by military contracts and government contracts, and so in that situation, it looks like we will have to adapt, and I'm not sure what that adaptation will involve.
Yeah, and I think sorry, go ahead.
Please go ahead, Blaine.
I think from my side, just one takeaway is that low Earth orbit and these constellations, they have great promise because again, it's really expensive, yes, but so is building a nationwide 5G or in the future 6G network. I mean, you think about the way that terrestrial networks have evolved. You need denser towers, you need more towers, you need more bandwidth, and correspondingly, it's more cost. They have a lot of promise to bridge the digital divide, all these buzz phrases that we use to connect the unconnected. But it's also very clear that there's not enough supervision, there's not enough coordination, there's not enough guardrails in place. And if we're going to really realize the full potential of these constellations, that's going to be very, very important because, yes, again, today Starlink is looking financially, economically pretty plausible. It looks like they're actually doing okay, but that's going to change dramatically if we start to have a couple of collisions and then we have more collisions and then the whole thing just, it ruins the party for everyone, not least of which Starlink. And I would wonder, to what extent, I was in a U.S.-China dialogue a few months ago, and one of the attendees from China was saying, yeah, the attitude in China towards the risk of space debris, or at least his attitude was, if a collision happens, that's obviously not good, but when that time comes, the market will take care of it. We'll have lots of, innovative entrepreneurs that jump in and figure out a way to solve this problem. And I certainly don't fully subscribe to that, but I also do kind of, what necessity is the mother of invention, as they say, right? And so if, God forbid, there were to ever be kind of a, collision event in low Earth orbit, I would like to think that a lot more resources and a lot more attention would start to be paid towards figuring out how to solve that type of problem. But I guess, in any case, I think there's a lot of promise from these constellations, but we need to be responsible and thoughtful about how we try to use that.
Yeah, I think these are some very important points, and in fact, I'd like to wrap up and say that while you have shown the Starlink is breaking even kind of, but then when they have the competition, when OneWeb gets into the game and Kuiper gets into the game and the Chinese get into the game, they're going to lose market, and that's the point of time when things will look a little different. I don't know. I'm not an economist, so I can't say that. But I do believe that if there is a competition, that there will be issues. And as you said, that the administration always lags behind technology, and that's a fact. I mean, wherever you look at, I mean, the technology goes far ahead, and then somebody says, wait, we have to regulate this, we have to register this, and all that. Rest of the thing keeps coming along. So I guess that's going to be an unending kind of situation. But the fact is that at least people are talking about it. The people have, uh, envisaged that some of these things can happen. This, I think, is a good sign. So I think we can now close this discussion, and I'd like to thank all the three panelists who have really given us a lot of food for thought. And I think putting this together will definitely contribute to the overall discussion that's going on the use of the low Earth orbit for the constellations. Before we end, I think we need to have a few questions to be answered. Shreya, you have been seeing the questions?
Yes. So we have a question here. Can you check the chat? Able to see?
I think, there is this question which says, studies like this have already shown that the LEO orbit is getting significantly affected by the greenhouse gases as well, potentially increasing the risk of degradation of satellites due to the increased density. In addition to this, we have space weather hazards and risks which are not so predictable at the moment, leaving the LEO constellations even more vulnerable. So the question to this is that now the question is, who takes the responsibility of ensuring these assets? I think Fabio is the person who can answer this.
You're on mute, Fabio.
Yeah. I mean, that's a question, because of course all these new elements put on the table are affecting the insurance market. So you have to be very, very cautious, in terms of getting insurance for this. And to be honest, back in the day, you would have insurance per satellite, or you would have insurance per maneuver sometimes. Most of the time, I mean, the insurance that is given is per launch. When the launch happens, because that's always seen as the most dangerous phase of the space activity. So we are entering in a new domain, to be honest, because, like you were mentioning earlier, all these satellites need to be substituted to make sure that the services are provided. So we need to see what happens. We're arriving at the time when the first batch of satellites are arriving at the end of their lifetime, and what is the risk there? Do we need to insure that moment? We are really entering in the uncharted territory, to be honest with you. And I think the market will have to react accordingly.
And the insurance market will also have to start looking at some of these issues. Yeah. Another question is, who would be responsible for any damage caused by the degradation and then resulting in a potential cascade of debris impacting other satellites? Well, I think it's more or less similar to the previous question, except that I think here he's raising the issue of liabilities.
Yeah. If I mean, it's always a legal question. I mean, it's going to be a challenge as well, okay? Because international law on the point is quite vague. Because the international law, you have, I don't want to make a lecture here, but essentially, if the damage occurs in orbit, let's say in low orbit, international law says that the damage must be caused as a result of fault by the state or by the operator, and the state on behalf of the operator. So where is the fault here? If the satellite the damage is caused by debris, as I said earlier, there is no obligation to remove the debris from orbit, so there is no fault there. If you're deorbiting the satellite, at the end of its lifetime, and that causes a damage, again, where is the obligation? Where is the fault? So internationally, it's going to be very difficult to go through international law. Even if you may know who is responsible, but you cannot get compensation under international law for that damage. So you have to find alternative way to settle the matter.
In fact, I don't know if you can also assign a debris to to a program or to a country.
Exactly. Yeah.
Yeah. We have a third question which says, why doesn't any organization consider designing a super electromagnet that is to be launched in orbit, say one in each quadrant, starts at least pulling the iron bits 20 to 40% into allotted zone to be sorted. Okay, this seems to be something related to debris management. But the point is, I don't know how much of iron is there, or how much of aluminium and other metals are there. Blaine, would you like to take this?
Well, yeah, I guess a couple of non-expert opinions here. I mean, I guess if you had a very powerful magnet, a powerful enough magnet to where it could actually attract pieces of debris, there's a chance that would also impact some of the electronics on functioning satellites, and it could actually end up being, more harm than good. Um, Maybe one comment on the previous couple of remarks about who takes responsibility and liability, this type of thing. I heard a really interesting idea and a couple of weeks ago, which I really I like, and I hope that one day we can get towards this of having a fund, let's say globally managed fund somehow, and every time you launch a satellite, you need to put some amount of money in this fund, and if the satellite has any kind of issue, let's say $100,000 or $1 million, whatever per satellite, and if the satellite has an issue, then the fund gets used to help pay for cleaning up the satellite. And once you responsibly deorbit the satellite, you can get your money back. Or if you then want to launch a different satellite to be in its place, then that money you already paid acts as the deposit for the new satellite. So I think these type of initiatives, in the absence of having very fast moving and easy to coordinate international discussions, because it seems like the international discussions are all rather procedural and it takes a lot of coordination. Having maybe simpler, more directly economic, let's say, incentives like that could be one way of making sure that if the worst case scenario does happen, there's at least some money available to be thrown at this problem to try to clean it up, and also some level of responsibility. If you're the one whose satellite causes a collision, at least there's a deposit that you've paid, and that deposit can be used to help clean up the collision. But yeah, it's a complicated problem.
So, I mean, I think the way I mean, what you said, it seems that like there is innovation happening in the technological world. Similar innovation perhaps is required in legal and administrative world as well. James, would you like to say anything as a closing comment?
Well, I think we've covered a lot of what I wanted to say. My main thing is just that I think this shouldn't be the normal way that people do things. Just break things first and then try to fix it later, because we're dealing with some non-reversible consequences, and we do need to address those.
Somewhat like the 2-degree jump in the climate change equation, right?
Yeah. Experiment that's going on.
Yeah. Okay, I think we are used up our time as well. So it has been an excellent discussion and some very good questions as well. So thank you to the audience, and thank you to all the three panelists. I think we have really discussed this subject very well, and I think we each need to have some more thinking on the various points that we have talked about, and I hope that there's some sort of a report or something will come out of this deliberation. So I hand over to the organizers. Shreya, it's yours.
Thank you so much for the very insightful discussion. I really enjoyed it, and so did our audience, I'm sure. So this will be recorded and put up on the Spaceport Sarabhai YouTube channel for everyone to view later. And we really look forward to engaging in more such discussions. And we have a playlist of very interesting discussions relevant to space law and policy, both in India and international. So please check out our playlist. And thank you so much to all the panelists, to the moderator, for a very, very exciting and interesting discussion.
Thank you once again for this opportunity.
Thank you very much.
Right.